Alright, so we're now going to construct an HTML builder so that all of this code is more understandable. So we're going to start by defining an HTML element because that's what is going to be the building block of just about everything that we do with HTML. So I'm going to make a class called HTML element, and this is going to represent just a single tag, like the p tag here, for example, with some content, maybe some text, but it can also contain other tags. So this particular tag can contain other tags. For example, here we have an unordered list tag, which contains a bunch of list item tags. So we're going to support this scenario. Now, in the HTML element, I'm going to have a bunch of public fields. In this case, I'm not going to be doing properties. It's too complex for our example. So I'll just have public fields called name and text. I'll also have a list of child elements. So public list of HTML element called elements, and I may as well initialize it straight away. And we'll also have, perhaps we'll do indentation, because when I run this, you can see that it's all output as a single line. Maybe I want it looking a bit prettier when I output everything nicely formatted. So I'm going to have an indentation level, the size of the indent. So that's going to be private const int indent size equal to 2, for example. So we're going to indent everything by 2 spaces. Okay, now let's make a bunch of constructors. So I'll make an empty constructor, but I'll also make a constructor which initializes the name and the text. So let's go in here and initialize the name and the text as well. All right, I'm going to reduce some of these since they can now be simplified in C#7. Even though ReSharper hasn't caught up to it yet and still complains about the question mark, we're going to disregard this. So what's going on now? Now we want to output this HTML element as a string, and we're going to keep using the string builder because it's a nice builder. It's a convenient way of building up strings. So what I'm going to do is define private string toString impl. So this is the implementation of toString that we're subsequently going to output in the official toString override, but we're going to have an extra parameter for the indent. And that's precisely what we're going to be using when we implement the ordinary toString. So if I override the ordinary toString, that's going to return toString impl with a starting indentation of 0. Seems obvious enough. So what we're going to do here is we're going to make a string builder. We're also going to make the current level indentation, and this is going to be interesting. So we have the indent level, how many steps have moved from the left margin, and we have the indentation size. I'm going to use spaces to indent. So what I'm going to do is make a new string where a single space is going to be repeated a certain number of times, and that number of times is obviously indent size multiplied by however many indents we actually need. So indent size times indent. Okay, so now I need to append the opening tag. So that's going to be sb.append, and here I'm just going to use string interpolation. I'll append the indent, which I have called I, followed by the tag. So here is the opening, and then the tag name, closing, and then, well, we may as well do append line. Let's just put a line break at the end of it. Okay, so that's our tag. Now the tag may contain some text, so I'm going to say if not string is null or white space text, we're going to output the text as well. So here I'm going to append, first of all, an indentation similar to the indentation we have here, but remember we're now outputting text, so we need to indent by 1. So I'm going to copy this over, paste it here, but this time round it's going to be indent plus 1 here. So that's the indentation for the text. Let's put a semicolon, and then I add the text as well. So sb append text like so, and then we may as well do append line. So let's put a line break at the end of it. Okay, so that's the text. Now we have the children. So if this tag contains a bunch of other tags, we can do a for each. Once again, we can say for each of the elements. So for each var e in elements, we sb.append, and here we just do a recursive call. So we say, we take the element and we do toString impl, so it's a recursive call with the indentation level of indent plus 1. And that's how you get the nested indentation for each of the inner HTML elements. And then of course you have to close the tag, so this is similar to what we have here except with the slash. like so. So close the tag, and we return sb.toString. So we return the overall string. Okay, so now we have an HTML element, and we may as well build an HTML builder, which is actually a convenient API for constructing a tree of these HTML elements. So let's do that. So I'm going to have a class called HTML builder, like so. Now I'm going to start the HTML builder by specifying the root tag, and I want the name of the root tag because we're going to have some kind of root. So I'll have HTML element called root here, and I'll initialize it. Just put a default initialization. This explains why I made the default constructor, so I don't have to specify anything here. But when I go ahead and I make my constructor, when I make an HTML builder, what I can do is I can take a string which specifies the root name, and then what I can do is I can assign it. So I can say root.name equals root name, but in addition I might want to store it as a variable. We're going to need it in just a moment. So I'll initialize a field with this parameter as well. Okay, so now that I have this kind of API, I can add a method to actually add a child. Public void add child, string child name, and string child text, and this adds a child to whichever object I'm working with. So I make a new HTML element with child name and child text, like so. And then, of course, I take the root element and I take its elements, and I say root.elements.add and add this particular element. Seems simple enough. This approach doesn't scale very well, by the way, but it's good for kind of showing a overall design of the builder. So now that we have this set up, we need a few more pieces actually. We're not done yet because we want to output this as a string. So we implement the toString override here. Interesting that it doesn't complete. There we go. So here we return and we take the root and just do root.toString. That's how we return the string representation. We might also want to have an implementation for clearing the entire builder because our builder is stateful. It keeps this root. So we may as well clear it in some sort of method. So I'll make a method called clear. And here what we're going to do is we're going to reset the root. So I'm going to say root equals new HTML element, but we want to keep the name. And that's why I made a field here called root name, because we want to keep that name. So I'll say name equals root name. There we go. So we have this clear method. And now we can start using the whole thing. So we can actually have a similar construct, an unordered list with two elements, but we're going to be using an HTML builder. So I'm going to say var builder equals new HTML builder. The top level root name is an unordered list UL. And then I'm going to add the children. So I'm going to say builder.addChild list item called hello, and I'll just duplicate this and put world in here. So these are the two items. And then we can once again write line builder.toString. Actually, the toString is redundant. And if I execute this, well, we forgot a closing round bracket somewhere. Let's take a look. So we have an extra round bracket needed here. And if we execute this, well, you see it's now much prettier because we added the indentation, but really the benefit isn't just the indentation. The benefit is that we've structured it in an object-oriented way. We've built up a tree, and we essentially made a special construct called an HTML builder, which is its sole purpose in life is to build up trees of HTML elements, and this is the result of its output.